Okay.
Good afternoon. We'll wait a few more minutes before we start this webinar. I see people can put on their cameras and unmute. Sophie, can you confirm? Are you allowed to unmute? Yeah.
Yes, I am.
Great. Perfect.
Okay. Okay, yeah, there's people pouring in. So I think it's good, yeah. Okay.
Yeah. Shall I do a quick introduction, Nicholas?
Please do.
Nicolas, yes. All right. Welcome everyone by this webinar for the Big Picture project. Today we have Nicolas Statonikos, if I say it right, from the UMC Utrecht. He's a PI in the Department of Pathology, and his focus is on AI development, but also on AI implementation. In fact, Nicholas is with the project from the start. He plays a instrumental role in the coordination of the cancer node, and is also has done a lot of work on actually setting up the local pipelines, local workflows to get UMC Utrecht data into the Bigpicture repository. And we asked Nicholas to share his experience with how to set up these local pipelines, workflows, how to select data from your local systems, and how to prepare it for submission to the Bigpicture repository. So the focus of this webinar is very much on clinical data submission, of course. So I think it's mostly of interest for other beneficiaries, but also for partners that will hopefully also contribute to the Bigpicture repository in the future. Just some practical points. We can have questions either in the chat, but preferably by raising your hand, and I will try to monitor that, and we can have them during the call.
Sure. Thanks, Rick. Yeah, as Rick said, if anybody has questions or something is not clear, let me know. I'm gonna try to convey a little bit the experience that we had so far, while giving an overview of how upload of data in Bigpicture works. Hopefully, it doesn't become too daunting. So maybe it becomes clear. I hope it becomes clear at the end. So, yeah. So, anyways, as I said, as Eric said, my name is Nicholas Statonikos. So I've been from the beginning. So I've from the beginning we started to work on the data upload. So because that's the main goal of the project. Right, sorry. And the main goal is to make a repository of images, right? So this is the main goal of the project, right? So everything else is just to facilitate that process, right? So and the idea behind it, so the more lofty goal is we want to have and it becomes much more important as we see politically speaking that to have like a European repository of images, not being relied on different repositories from different countries. Since we can do it, might as well be able to do it, right? But in order to do that, you have to set this up in a correct way. And that's the first, let's say, problem we encounter, because people have worked in research and have done research using pathology data. They usually have a specific workflow. So when they come into Bigpicture, it becomes quite, let's say, daunting of a task, because there's so many things you have to take care of and arrange that sometimes there's a sort of mismatch of expectations and reality. So when you do research, so far from things that things that are published and so far, there's basically two main routes, right? You either use some open source data set that's published, or you gather yourself the data, or somebody gathers it for you. And then from that data, you might use the annotations as they are, or you have to annotate it and add some clinical data. And you save that data somewhere, you keep it in a local repository, and then it has its own format. Maybe it's in Excel, maybe there's some fancy database behind it. But I think a lot of people will agree that seeing how big pathology labs is and how, I mean, these are not very fancy, usually not very fancy studies, right? So my experience is that most of these studies do not employ some specific data manager. Usually when a PhD student does this research, they're going to be the data manager. And this is just let's just show some screenshots of like folders in my folder where I keep my data. I mean, it's basically folders with studies, and then in there's like clinical data and images, and that's about it. Some of them are anonymized, some of them are not. Usually I try to do this in the correct way, but my experience is that every project is kind of unique. I mean, every time, you gather different data and you want to do different things. So in that sense, and if you work by yourself, like in one center, things are usually easy. You just gather the data, everything goes into a specific folder. It's easy. If you work in a multi-center environment and you have to gather data from multiple sources, of course, it becomes complicated because you have to arrange all the necessary documents, all the opt-outs, all the ethical approvals, all the data transfer agreements. But at the end, practically what happens is that you gather data and you send it to one person. He's either the researcher or the data manager, and then they have to make sure they harmonize the metadata in some sort of way, and they save them in some way. And there are good examples of this, of course, but there's also most often they're not not the best way of not best practice in that sense, right? And usually when you gather data from different research from different centers, you have to harmonize that metadata. It has to be a specific format. This is more of a thought experiment, but I've had this challenge as well. If you take something that somebody published 5 years ago from your department, from your team, and you try to, and the people that did the study have left, and then you try to replicate the results, or maybe run new models or add some extra annotations, usually that becomes quite difficult. So study replication is very, and at least that's my experience, very person focused, right? So the person that was before knows how the data was structured, and they can probably run the results. And then maybe they've left some good explanation how the data works, but there's no standardized format, not even the same hospital or site. And again, some sites do this much better, but the majority not always, right? So that means that we need to do better, right? We need to do better as researchers, and we have to, and there's a million standards out there, and there's a lot of way of doing this, and we can invent, of course, a new metadata standard, and that's going to solve some problems, going to create other problems, right? But if you manage to actually make that repository, then you can start maybe enforcing a standard, and then you can have a more consistent level. And especially if you do this on a European level, that increases the pool of available data that becomes more interoperable. So it's a very practical and a very pragmatic way of a need that Bigpicture is addressing. So as Rick mentioned, and I mentioned in the beginning, I'm going to focus only on the clinical because that's where I come from. That's what I work for. And I'm going to explain a little bit how the process works so far. But I'm going to talk more about the practical stuff. So the software needed, the metadata, the structure, and the issues that we've encountered so far. So the process in Bigpicture is this is a little bit how it is, right? So through sites, through labs, through clinical sites, and via the nodes, the idea is to gather the data, right? So there's I don't know, 40 sites or 40 hospitals or partners in any case, and then there's 6, 7 cancer nodes, and the idea is that those sites they submit the data, and that is the the process, but that's not the practical process how the data gets in the repository. So I mean, practically, the site that has the data has to extract the data from their system. They'll have to do some sort of pre-processing, and then they'll have to be converted to the Bigpicture standard. Once it's converted locally, then it has to be uploaded to a node. And after it has been uploaded, then it's ingested into the repository and it's available in the catalog. So then people can search for it. Oops, sorry. And then if you look a little bit like the infrastructure or how that looks a little bit from the line on the left side, these are the actions you have to perform locally. And then from the right side is what happens once the data is uploaded. So there's in the sketch, you'll see a lot of blocks. And that's because there's a lot of actions that need to be happen on a local level. And one of the problems of being encountered so far in the big picture that I personally also have encountered is that the actions left of the line are actually quite a lot that need to happen. So I'll try to kind of get into that and show a little bit like what the issues have been so far. But I think the problem is because in essence, the idea is sound. You know, you have the data, you convert it into a specific format. This format is common, it's described, it's published, people can see it. And then you also convert all the images in a specific format. So then you have harmonized the metadata, and then it's much more easy to have an interoperable repository. The problem is that the data come from the clinical side, they come from pathology labs. And usually people have to dive into their laboratory information management systems and in order to get the data out. But the LIMS are not optimized to save data. They're optimized to carry out lab work. So the idea is that the LIMS is used by people in the lab in order to do their tests, to prepare samples, and to prepare slides for pathologists. And then the LIMS also offers the pathologist a way to compile the report. And the report is not meant to be plugged into other systems to be further data used data analysis. And that's the difference with the genomics domain, because in genomics domain you do the tissue processing, you run the tests, and what comes out is a report which is meant to be read, but also you can use that data to interface with other systems. The pathology report is optimized to look very well when you print it as a PDF, and that's a big problem that we've encountered also in Bigpicture, because then this data has to be machine interoperable, let's say. So people that haven't worked in a pathology lab, they have maybe some expectations. And this is like a screenshot from TCA where you have this overview and this dashboard of the data. You can click on everything, and then you can go have a very fine-grained control of the data, and can see and can very easily export and extract data. But the reality is that this is how our data is. It's basically, just text that describes what we see and then the microscope. And then we have some coding for that, of course, and things are a bit standardized, but that's about it. So the question is how to get from the reality into actually what you would expect to see, right? So I'm going to talk about my own experience because this is what I know and what I've been doing. I can't really talk about the other sites that well. I mean, we've seen how other sites work, but I think the experience is similar, not the same, but very similar. So we start with we do a query in the LIMS, and especially on our site, we get for one row one report, right? So it's kind of flat. You get the export, and then this is kind of how it looks like. Basically, some information when it came, what type of material it is, and then microscopy conclusion and the diagnosis. And then for the slides, we have a database, so that makes things, at least on our side, a little bit easier, where we have we can very kind of easily export the metadata of the slides, and then on which case this is connected. So we basically have two data points, which have to be combined in order to make the big picture database. So that means that at the MCU, with these two, then this has to become a big picture XML for the biological beings and the specimen, and we have to recreate that hierarchy, right? And then for the slides, the same thing. All the metadata have to come out the slides and then be into the standard. So one thing you'll see here, and maybe it's not completely clear, but I mentioned it's a hierarchy. So a specimen belongs to a biological being, and then a block belongs to a specimen, and then a slide belongs to a block. And we have this metadata defined on how this has to work and thing. The problem and the reality is that sometimes this hierarchy is not reflected in our limb system, or it might be reflected, but it's not always clear, and all those lines are not completely clear. So then you have to take this text, this data points, and you have to convert them into this hierarchy. So you have to kind of recreate everything about that. So, and of course, just adding reports and just adding slides does not make the data that valuable. You want to add more variables in your data. You want to extract attributes, and you also want to convert the fields that you're using into some sort of recognized ontology. Because I can talk about the short codes that we're using in the Netherlands, and I'm pretty sure other pathology in the Netherlands will be able to recognize these, but they might mean nothing in a different European country. So then these codes here, which are locally, which is a local coding scheme, have to then be converted into a SNOMED CT scheme, right? And the same thing has to do also, and if I go back a little bit, I can show you. Same thing has to do, and I can, if you can see here, with the slides and the stainings and everything, because a staining that we use and we call it in a specific way might be called differently in a different country, and they also might be using different antibodies. So when you want to do some analysis, it might not be, let's say, compatible. You might be looking at different antibodies, and so then, sorry. So then it might be difficult to do this type of research. So in our case, as I said, we take the slides. They have to be converted into DICOM, and then they can be uploaded in Bigpicture. So one of the the particulars of DICOM is that the metadata that you have in a file have to be in headers. So you have to make sure that when you do this conversion, they can go into the headers, which is not the case when you originally scan the data. So when you scan a slide, it has some basic metadata, which the scanner produces, but it doesn't have any other metadata in it. So you have to insert that. And that's also one of the complications. Okay, so how does this work on our site? Currently, let's say, so I take this file here, the export from the limbs, I take the slide information, and I combine this into one file, and then I load it into SlideTab, which we're using at the moment. And in order for SlideTab to be able to process and analyze the data, I have to set up a set of rules, okay? So that I have to explain that, the specimen and the diagnosis is connected this way. So then in an overview, how the workflow at the moment is, I have to load data in SlideTab. I have to do some sort of pre-processing. And that's what's also something that SlideTab can do. So you load the metadata, you pre-process it, then it checks everything and makes sure it's valid. You can the attributes follow the Bigpicture standard, and the images are then linked, and you can they actually exist. And when that is done, you can then do the processing, and that's the actual conversion where we do everything into DICOM. and then they are exported into a folder, and then encrypted and uploaded. So this is the main workflow overview, right? So this is the big picture. But this is something that we can do now in the project. We have the tools and we have the utilities to do this. But the problem is, how do we got there, and what are the issues that we encounter in order to get there? Because we had to do a lot of iterations. So in order for SlideTap to work, we have basically four components, right? One is the whole site image dichomizer. The other one is a set of rules and logic, yeah, and this is site dependent, and big picture metadata interface, and big picture SlideTap. So the first component, the whole site image dichomizer, this is basically a utility to convert the whole site images from proprietary formats into DICOM. The problem is that DICOM is not widely used in pathology, which means most sites have whole site images in a proprietary format. That creates an issue because digital pathology, we've had whole site images for the past 15 years, and it's been in development all this time. A lot of formats have been created in the meantime, which means that if you want to cover all of those formats, it's quite broad, and the experience is that you will get problems. So when you try to conversion, and this also has to do because a lot of these tools like wholesale dichomizer has dependencies, and it might work in one environment, one platform, so in Linux, but not Windows. And this is something that I also encountered very often. This is just my daily chat with Eric, who has helped me enormously with his project, where we're trying to figure out what's going wrong, why we can't convert. And it turns out it was like one package, which is like the wrong version. Instead of the 2.18.3, it has to be 2.18.4. And this is one of the issues that we've encountered. Like a lot of these tools, they have too many dependencies, and that actually might break the whole process. So the next step is the logic and the rules, and this is site dependent, meaning that every lab, depending on the LIMS system, depending on how they do the reporting, they have their way of storing data. That means that every site that wants to contribute data has to develop this logic and rules themselves. And it's kind of difficult to have make a very generic version that will work for everybody. And that's one of the reasons why there's no, let's say, one solution that can help every site at the moment. And we have to kind of help every site separately in that sense. Again, this comes back to that, most LIMS systems, they don't have very well-defined ontologies. So you have to, know how the system is works and how everything is stored in order to get the correct data out. So one of the tools that's like basically the main workhorse for Bigpicture is the metadata interface, which helps to manipulate Bigpicture data. So if you manage to load your data via the Bigpicture metadata interface into Bigpicture object, you're halfway there into having your data in the correct format. However, you have to combine that with the whole site image conversion process, where you have to send some metadata to the DICOM format, and that's also one more step of complication. And then SlideTap is a web app, so you need to kind of define like the models on how a web app works. So if you want to roll it out locally, let's say, and that's something that we also encountered that we didn't have experience with, and we had to request help from Eric to set it up. Okay, so once you're done, so you have your data loaded in SlideTap. You've done the curation, you've done the processing and the conversion. You can do the validation in SlideTap, and then you can do the export. And basically what happens is that SciTab just writes everything into a location on a drive. So once you have that in that folder, you can then encrypt the data and upload it to Bigpicture, right? And this is also one more thing, which is a little bit you wouldn't normally expect it. So when you would submit data into pathology data onto some sort of open source archive, like let's say Zenodo, for example, that encryption step is not necessary. But because we are using a repository and architecture based on the EGA, on the European Genomic Archive, there's an encryption step in it. So that makes things a little bit more complicated, of course, but it's a necessary step for the repository to work. So I'm gonna take you through one example, and this is kind of like our journey so far, right? So this is what we try to do. So we started, I think, 2 years ago. We said, okay, the first data set that we will submit is breast cancer biopsies. So we pull from the archive cases from 2017 until 2022. So 5 years in total, 5,000 cases, and around 45,000 whole site images. So when we first started, because we already had done a test and that went well, but we were still at the first 1.0 or 1.1 version of the metadata. So we were using the Bigpicture converter, which was basically a Python program, and we had to we had to adapt that to our own local needs using those logic and rules that I mentioned before in order to do the conversion. However, this is a running project. A lot of things change. Metadata change, new requirements are coming in, and at the end, using that script, we had to invest a lot of time. There was a lot of feedback loops going back and forth. New feature, update packages, have to make it work again. So the problem is we invested a lot of time to get it working, that script. And at the end, I'm going to go back here. I don't know if you can see it, but there's a lot of well, I think I left that out. But there was a lot of hacks and workaround in order to get that to work. So it would work, let's say, with one data set, but it wouldn't work with the next one because you already had, too many workarounds. And then the dependencies keep breaking because, as I mentioned, there's a lot of packages you needed in order to do this, and start crashing all the time. So at the end, we had to make a decision. And so basically, we said, okay, we have to do this differently. At the meantime, Eric was already working on SciTap. And that seemed to work quite well, and it was more mature. So we then decided to switch over that. So, but before we did that, because during that time, we saw that working on this large data set with 45,000 images, when you start testing and something goes wrong, you're going to discover it 3-4 days later. So it doesn't make sense to start, such big. So what we did is we, of course, decided to split the data set. So this data set became 10 smaller data sets, smaller chunks. And of course, that makes it a little bit easier to work with. And the other problem that we had, of course, is that because 45,000 images is around 45 terabytes of data. And if you then want to encrypt the data, you wouldn't replace the original data. We would just make a copy of the encrypted data. So if you have 45 terabytes, you have another 45 encrypted data, which increases, your storage significantly. So splitting it into small data sets helps in that sense. So in the second iteration, we ported everything to SciTap. And now the teams are working on the version 2.0 of the metadata. So we decided also to switch to that. Now, this was a version that was underway, so it was under development. So that had its own risks, which means that if there were any changes, we will have to, port those changes back with those issues, of course. And we split it into 10 data sets. That means that we had 500 cases and around 4,000 images. The problem is that even though we had all this work invested into making the big picture converter script into with that logic and rules that we needed, that wasn't possible to port it into SciTap, which means we had to start from the beginning. And of course, not all the features were available in SciTap, so this was kind of like trying to build the airplane while in flight. And again, even if you have the dataset split, it's still 4,000 images, 4 terabytes of data. And that means that when we wanted to curate the data in SciTap, it of course was very difficult, and there was a lot of strain on the infrastructure. And of course, when SciTap is a web app, so that means it has to run on a server. When you run something on a server, it needs a host name, it needs a certificate, even if it's local, right? So you have to arrange all this infrastructure in order to do this. So that requires some extra, let's say, IT support. So now instead of like being one developer or 2 people doing this, you have to involve more people in order to help you with the infrastructure. So okay, so we got SciTap working. We managed to convert datasets, and we've exported datasets. So the next step is to upload to Bigpicture, right? So using Bigpicture metadata interface, it has a function which is called upload folder appropriately, and that lets you upload the datasets to the thing to the repository. And it also has a very handy feature which does encryption on the fly, which means that you give a folder as an input, and then while running, it does the encryption, and then it uploads the encrypted data to the repository. So it doesn't have to do that double save of the data. In order to do the encryption, and this is how encryption works, is that you first have to do a checksum, right? So you have to, check the integrity of the file. You do the encryption, and then you again calculate the checksums, and then you upload them to the repository, and then you again do the checksum on the repository to see if that is correctly uploaded, because there's no way of reading the encrypted data when you do the upload. So in order not to do all those checksums all the time, you do it once, you save it in a database file, so every time you retry, it can read from the database a file. But the problem is that if you are uploading 4,000 slides, right, and then something goes wrong, then you have to restart. And because of that, that database, it kind of goes a little bit faster. But one issue that we had was that it wasn't always clear what went wrong. So it would upload everything, try to upload metadata, crash, said something was wrong. So I had an instance, for example, that one of the observations, something was empty, so it was missing one attribute, and everything was crashing. So I had to go manually and kind of double check all the XMLs, make sure that they were okay. And these are things that weren't easy to catch. So again, when you're uploading 4,000 slides, if it takes a whole day, you'll discover that error at the end of that day, right? So it makes it a little bit difficult to do these checks. So the problem is, like, we started 2 years ago with a best practice data set, but again, it's a project which is ongoing, right? So you expect to have issues, but the problem is, like, we're still not done. So we still haven't managed to upload the whole best biopsy data set. The good thing, though, is that the latest version of the metadata is released. And most of the tools that we're using have now a stable release, which means that we don't have any more that plane on flight and try to fix the plane while on flight. So we managed past month to upload 3 of the data sets that we had, 3 out of 10 actually. And we had some minor issues, but we're quite confident that we can do the rest, let's say. So if you want to do if you want to upload data, at the moment there are checklists and there's better guides, and we're working, I think, all together, like making these guides more complete. But there are places to start from. So one thing would be starting from the MBIS website. There's like a submission guide and a preparation guide and how data has to be formed. So it gives you an idea of how things are expected. There's a checklist, which is there's a working version of that on the steps you need to take, because before you start uploading data, you have to first make accounts, make sure you're added to the right groups, and then you can get the actual to upload data. There's a separate GitHub for the project where all the code is uploaded, and then all people that want to do that, they can download the repositories in order to work locally. And all the communication is done in Slack, and that has been enormous help, because whenever you have an issue, you can just send a question, and you can have 2 or 3 people looking at it, and you can solve the issues much more easily this way. So based on that experience and based on the issues that I personally encountered while doing this, I can't imagine that every site will be successful in doing it, in the sense that it can be difficult, and if you don't have the local expertise to do it, it might be a problem. So we are working on a sort of generic, let's say, version of SiteTap. That means a version where if you have the data in a specific format, you will be able, let's say, to more easily do this conversion. And we are testing it with a couple of people. So hopefully that can also be one more tool that can help with the data upload. So yeah, I think my experience is, at least for a couple of past months, that it seems to be mature enough at the moment. So I think now is a very good time to buckle down and start uploading. Yeah, so I think that was a little bit of my experience so far. So I don't know if everybody has any questions or comments. See a hand. So somebody raising a hand, but I don't see it anymore.
Think. I just flashed it.
Thank you.
Yeah. It was a very nice presentation, very structured, and I feel I have learned a lot. And you also described the progression very nicely. Thank you.
You're welcome, man. Glad to be of service.
So I think, Nicholas, thank you very much. So I think there's a couple of takeaways, right? So that's split your data sets in smaller subsets, at least initially, when you start testing and trying.
Yeah. At least initially, yeah.
Yeah. And one other point that you raised is also set up the local infrastructure, let's say the IT support. Can you elaborate a bit on how you've done that? Like, what are the things you need in-house to get this working?
Yeah, so I always say you have to have a very good relationship with your IT department, first name basis. You have to remember their birthdays, bring them cake, bring them pretzels. That helps. But basically, a lot of the tools, they have some requirements, right? And they are so SiteTap, for example, you can make a Docker and then run a Docker, and then you can basically host it that way, and that works quite well. But the question is, can all sites run Dockers on their infrastructure? Do they have a place where they can do that? If not, somebody has to set that up for them. I know that Work Package 2 are prepared to support the sites in that sense. But there's also a way to do things locally, right? So you can also, if you have a dedicated workstation, you could do this, let's say, there. You don't really, you wouldn't need a server. So my advice would be, you first start locally, just find a good workstation, download the tools, try to make it work. Work with start with a small data set, try to convert that, see where it goes wrong. The logic is very important to make sure that your data can be converted. And I think in the meantime, if you have that working, you could then, I think, request support locally, because again, even though you might need it's a web app and you might have to deploy this on a server, it wouldn't be impossible. I mean, you're working locally with your own data. So in terms of data security and that kind of thing, I like personally, I mean, here on the UMC, we didn't have an issue with that. Usually the problem is like when you have to set up something that either has to be accessed from outside or more people have to access it. So again, if you work locally, you can start, get a feeling, and then, expand.
Are there other questions from the audience?
So I have
there's
a
one
question. If
there's
has,
one.
sorry, Michelle.
Yeah,
yes.
or two. Yeah.
Hi, thanks
Hi,
for the
Michael.
presentation. I had a question regarding the metadata in the DICOM images. So if I understand correctly, there's also a metadata stored by slide tab in the DICOM images, or how does this work?
So the DICOM image has two things. It has the DICOM tags, the DICOM headers, and you see here on the right side, and the pixel data, right? So the way that the pixel data is saved, I mean, it's not nothing so special. It's basically a tiled pyramid. But what's important is that you have to add all the headers. You have to fill in all the headers. And the idea of the DICOM is that so if I want to share a case with you, let's say we're doing consultation, right? And you're the pathologist and I have to send you a case. I will have to send you currently, I'll have to send you the scan slides, and I have to send you separately a file which explains what are those slides, which case it is, and all the clinical data. And DICOM doesn't have that. DICOM has everything in the format. And the idea is that you just share one file and it has everything you need, all the information in order for you to view the file. So if you see here on the right side, there's a patient name, it's biological being, and has a pseudocode. And here on the right side, it says, where is it? On which study ID it belongs to, where it was scanned, what type of species it was. So all of that is there. But if you scan slides, so if you have the normal whole size scanner, this information is not there. So that creates a complication when you want to share these slides.
Okay.
I know.
Thanks.
Yeah. But then I have two questions. So if, say, someone, data owner would have primary DICOM format in their archive, do you need to do a DICOM conversion for Bigpicture, or is it just straightforward to pull the DICOM as it is?
So I will answer this in a theoretical and a practical question way, because I'm not sure if there's anybody who has submitted
No.
data that was already DICOM. So I think we haven't encountered that yet. I think practically what happens is that because the headers are things you can read and you can anonymize, right? So you can change the headers. So you basically make a copy of that DICOM with anonymized headers, basically. Oh yeah, sorry. So I think that's what practically what you have to do. But again, I don't think we even can. And my experience, I think in Sweden there are several sites that I think are using now DICOM in practice, like standard. So we might encounter a data set with DICOM soon enough in that sense.
Yeah.
But again, we haven't encountered that. And I know that there were DICOM because it is a standard, but every so yeah, the DICOM standard is published, right? But it's not a piece of software they can download and use it to convert things. It's a document that describes how it should be. And that means that every company that implements this can implement it in their own way. So you might have a DICOM specific implementation from a specific vendor. So there's a possibility that you might have a DICOM format that is not really compatible with Bigpicture. I hope that's a small possibility, but I think that's a possibility.
If I can take my second question, it was related to I am like you. We are acting like pragmatic. We're splitting up the entire data set to have a possibility to submit it. But is this? I think we should have an agreement with work package 2 to understand how much we need to split it and for how long, and will the entire goal be to be able to submit the entire, or are this the restrictions that we need to follow due to the data amount and so on? That would be good.
I think Johan has his hand up.
Yeah.
I think he might want to comment on this. Johan.
Yes, thank you. So, what should I say? Did I take it up? Yeah. I think everyone that makes a first submission should always make a very small first submission. That's number one, because we get some, I mean, it's tricky to have the same idea of what should be done. So that's number one. Also, I think we are currently working on getting a better storage backend running, because the one we currently have is quite small. I don't think it will affect anyone, but if we get really big data sets right now, it's kind of unnecessary, I guess. But I think it's fine for most people to submit their data sets. I don't think it's too much of a concern, and it should also be possible to merge these data sets later on if you submit them in batches, and then we can in some way accommodate a new dataset XML with whatever metadata files that incorporates everything. I don't know exactly how to merge them, but it shouldn't be a problem to create a new entry in RAMs and then delete the old ones. Yes. I hope that answers it somewhat. But it's good if you like think you have a large data set, maybe and just submit a query to this BP ops mailing list, and we will look at it and we can give a good answer. What was it more? Yeah, and please look at the instructions on the bp.nvis.se website for how to structure the dataset, because we get a bunch of errors that are simple to avoid if everyone follows it, but then it's also not clear always how to follow it. I understand that. So if you have any feedback on that website, it would be very good.
Yeah, I've added also here in the submission guide.
Yeah, it's really good. Yeah.
Yes. You're absolutely right. I mean, if you just look at it, then it avoids a lot of issues.
Right.
Okay, so
are there other questions, or somebody who would like to, Nicholas, to elaborate more on one specific aspect? No. If not, first like to thank you, Nicholas, for providing this insight. I hope we didn't scare away people, and I was very happy that you ended on a positive note, that now we came to a point in the project where we have stable metadata. We have tools that can work with this metadata that are relatively stable, and I think the slide where you ended with, well, this let's say positive message that things are a lot easier now. It will still require some work, but we're in a good shape, and we're happy to take more data from beneficiaries. And as Johan also pointed out, it is an iterative process for everyone. So I think it's very important that we keep reaching out to each other and inform each other from in case any issues pop up, and then we can solve them. With that, I would like to close this session. Thank you again. Thank you all for attending. The slides and the recording will be made available on SharePoint, and I hope to see you again in the next webinar. Thank you.
yeah, thank you. Take care.
Thank you. Bye-bye. Thank you.
Thank you. Take care. Happy weekend.
Shall I send